In this video, I will be going over line integrals and how to evaluate them over a vector field. So let's say we have a vector field labeled f and a curve labeled c. The line integral of c over the vector field f is defined as the dot product of f and the dr, which is the tiny amount of change in the curve, and then f, and you do that over the curve. So I'm going to go over an example of how you would do one of these problems. So let's say our vector field is defined as this, and the curve we are looking at is the unit circle with center at 0, 0, and we are integrating it counterclockwise, sorry. This is what that would look like. So the vector field f, it changes strength as you go up. So it's going in the positive x direction as you go up this way, and it gets stronger. And it goes in the negative direction when you go down this way, and it gets stronger as the farther down you go. Let's get started on solving this analytically now. So the first thing you want to do is describe the curve in a parametric form. So the way we would do that is, since this is a unit curve, 1, y equals 1, we can say that we will make our parameterization variable t, and we will let it go, and the easiest thing to do is let t be this angle, right? Because we're going, our r is the same, we can just go around. So we'll start here, we'll start at t equals 0, and we will go around to t equals 2 pi. In this case, x would be equal to the cosine of t, and our y would be equal to the sine of t. The important thing to set is to set up your variable such that your starting and end point, such that when you have your t is the starting point, you start at the point you actually want to start at, and when your t is your end point, I'll say this is ti and this is t final, you end at the point you want to end at. And you go, so you want to go the right way around the curve. So if this was going the other way, I would want to make these both negative, because I would want to go around like that. But since I'm going around this way, this is how I personally would parameterize it. So our curve can be described as this. As t goes from 0 to 2 pi. Going back to the definition. So dr, what is dr? Well, right, is just along this curve. R at any point is just that. So dr would just be the derivative of this with respect to t. So our r is this, and our dr would be this. Now that we got the dr in terms of dt, we can write our line integral. So let's just rewrite this out. Dot dr. So I'm going to say our f is y 0, 0. We're going over c. Dot dr is negative sine of t cosine of t dt. And then our curve becomes t is equal to 0 all the way to t is equal to 2 pi. Right? So we need to get this in terms of t as well. So when we parameterized the curve, we said that y was going to be sine of t. So I'm going to say this y is now sine of t, 0, 0, dot negative sine of t, cosine of t dt. Now you just take the dot product, right? Just follow the notation. T is 0, t is 2 pi. Dot product is going to be this times this, so negative sine squared of t, 0. I guess we were only doing this in 2 dimensions, so we don't need to really focus on the z, because we're just doing it on z equals 0 plane. dt. You can just, I'm going to pull the negative out. Sine squared of t using the half angle formula becomes 1/2 of 1 minus cosine of 2t. The integral of 1/2, the integral of 1/2 is 1/2 x, or sorry, 1/2 t, minus the integral of the cosine of 2t becomes 1/2 sine of 2t, and this is from 0 to 2 pi. So at 2 pi, we end up with sine of 4 pi is going to be 0, because it's still the same as sine of 2 pi. Oh, yeah. So this is going to be 0 at 2 pi, and it's also going to be 0 at 0, so we don't have to worry about that. So what we end up with is negative 1/2 times 2 pi minus negative 1/2 times 0. So this is just 1/2, sorry, this is just negative pi. Does it make sense for this to be a negative number? Well, if we look back at it, going around the curve, you notice that this is sort of going against the current. So here, the current is going this way, and we are traveling against it all the way around. And then once we get down here, the current is going that way, and then we travel against the current to go back up there. So it makes sense that this is negative. Yeah.